For real number u, tan inverse u lies between minus pi by 2 and pi by 2, and cot inverse u lies between 0 and pi. Then evaluate integral from 0 to 1 cot inverse of 1 minus x plus x square with respect to dx upon 0 to 1 tan inverse of x dx. First of all, let's try to evaluate the numerator, which is integration from 0 to 1 cot inverse of 1 minus x plus x square into dx, which is equal to integral from 0 to 1 tan inverse of 1 upon 1 minus x plus x square dx. Here we use the property where cot inverse of x is equal to tan inverse of 1 upon x. In the next step, integral from 0 to 1 tan inverse of 1 upon 1 minus, taking x common here, we get x into 1 minus x into dx. Now 0 to 1 tan inverse of taking minus 1 common, so it becomes 1 plus x into x minus 1. Now the difference of x and x minus 1 is 1, so instead of this one I'll write the difference, which is x minus 1. Now since we know that tan inverse of x minus y upon 1 plus xy is equal to tan inverse of x minus tan inverse of y. Using this identity here, this integral becomes integration 0 to 1 tan inverse of x minus tan inverse of x minus 1 dx. Now using king rule here, we get integral 0 to 1 tan inverse of x dx minus integral 0 to 1 tan inverse of 1 minus x minus 1 dx using king rule in this integral. So it becomes 0 to 1 integral tan inverse x dx minus 0 to 1 tan inverse minus x dx. Now using this property, tan inverse of minus x, which becomes minus tan inverse of x, here in this integral we get 0 to 1 integral tan inverse of x dx, minus comes outside, so minus minus plus 0 to 1 tan inverse of x dx, and this finally becomes 2 times integral 0 to 1 tan inverse of x dx. The expression which we want to evaluate is this, and we found that the value of cot inverse of 1 minus x plus x square integration 0 to 1 is this 2 times of tan inverse of x. Using it here, I can write 2 times integration from 0 to 1 tan inverse of x dx whole divided by integration from 0 to 1 tan inverse of x dx. So this similar terms cancel and the final answer is equal to 2.